I like explaining, how it is rewarding to be able to ask a question that no one else has asked, to design an experiment, collect, interpret data, and maybe shed some light on some pathophysiological process that we didn't have a clue about before. So that is a really rewarding process.
Hi, I'm Kimberly McCorkle, Provost and Senior Vice President for Academic Affairs at East Tennessee State University. From the moment I arrived on this campus, I have been inspired by our faculty, their passion for what they do, their belief in the power of higher education, and the way they are transforming the lives of their students. This podcast is dedicated to them, our incredible faculty at ETSU. Hear their stories as they tell us why I teach. In this episode, we will talk with Dr. Polichnowski. Dr. Polichnowski is an associate professor in the Department of Biomedical Sciences at ETSU's Quillen College of Medicine and the recipient of the university's 2025 Distinguished Faculty Award in Research. Dr. Polichnowski is nationally recognized for his work on hypertension and chronic kidney disease. His studies have advanced understanding of how blood pressure, genetics, and environmental factors influence kidney injury and disease progression. In addition to securing nearly $2 million in external research funding, Dr. Polichnowski is deeply committed to mentoring future scientists and physicians and has directed ETSU's Medical Student Summer Research Program since 2017. Today, he joins us to share not only what he studies, but why he teaches. Enjoy the show. Dr. Polichnowski, welcome to the show. I start my podcast with the same question for every guest. Take me back to your first day of teaching at ETSU as a faculty member. And looking back on that day, what is one piece of advice that you would have given yourself?
Well, first, Provost McCorkle, thank you for having me. I'm excited to be here. I would actually tell myself two things if I had to go back to my first day of teaching medical students here at Quillen. One, I'm not going to know the answer to every question they ask, and it's not going to be perfect. One of the things that I've really appreciated with the opportunity to teach medical students is they ask really good questions that push me, that push my boundaries of knowledge. I learn something new every year from the questions they ask, and I don't know the answer to all of them. So it's that's something I would tell myself is to relax and just let that happen. And the not being perfect. I think a lot of us in research tend to be a little bit of a perfectionist, and like everything else, teaching is a learning process. You get better at it each year, and so I would just tell myself again, relax, just enjoy the process.
Thank you. Great advice. You built a nationally recognized research program in kidney physiology and disease. What originally drew you to teaching alongside research, and how do you think the two inform each other?
Yeah, it's a good question, and I would actually say I think it was probably my experience teaching fellow classmates when I was an undergrad student that probably drew me into research because it's such a logical process when trying to understand something. So I do think it was my passion for learning overall that got me excited. I had a strong interest in teaching fellow classmates material we were learning, especially when it came to how the human body works.
And that was as an undergraduate.
As an undergraduate, yeah. And but the two very much go hand in hand. Running a research lab is like running a small business. How successful your lab is going to be how successful your team is. And a lot of that is training and teaching them why we do this research, how to do things appropriately, correctly, following a process, teaching them techniques. And on the other side of the coin, being a researcher makes me a better teacher. I think one of the things that I like doing for medical students is providing a logical process. When I see something in a textbook that's not very clear to me, I will try to make those links for students, and my knowledge and research, I think, makes it easier for me to do that. But they really do go hand in hand, in my opinion.
Yeah, and the research makes you a better teacher.
For sure, yeah.
You mentor students at every level, from undergraduate to medical students and early career scientists. What do you see as your responsibility as a mentor, and what do you hope students gain from working in your lab?
Yeah, my role as a mentor is going to depend a bit on the level of the student, undergrad, medical, someone who wants to do a PhD. But I what I want to convey to all students is the importance. As a mentor, I think it does depend on the level of the student, either undergraduate, medical, someone who wants to do a PhD. But for all students, I want to convey to them the importance of what I'm doing in the lab and how it may impact patient populations, especially in this region. The importance of what I do, why I do it, but also the research process. I think it is this black box for a lot of people and including students. And so I like explaining, how it is rewarding to be able to ask a question that no one else has asked, to design an experiment, collect, interpret data, and maybe shed some light on some pathophysiological process that we didn't have a clue about before. So that is a really rewarding process. On the other hand, it's also very complex business. Research has a lot of moving parts. It can be frustrating. It's a slow process. A lot of the experiments we do, you're not going to lead to some groundbreaking result. They're going to be what we call negative data. And, it's hard to interpret or determine where to go from results based on that study, but it's all part of the process. And the last thing I like to tell students is the value of collaboration. I would not be where I am today without collaborators here at ETSU, other institutions, and importantly, the mentors that I had. I mean, I'm so grateful that I picked labs that I did, and it was not all that happened on purpose, some of it by chance, but I am very fortunate that I worked with people I worked with. I got just spectacular training, especially in my postdoc career. I worked with clinician scientists. They were nephrologists, but also basic scientists. And that really helped me view research from a basic science to a clinical perspective, translation perspective. I mean, they were asking big questions that the results could directly impact patient care.
Your research bridges basic science with real world clinical implications. How do you help students see the connection between what they're learning in the classroom and its impact on patient care?
This is one of the most rewarding aspects of teaching for me. Physiology is what I'm trained in, and physiology is medicine. So, I think I mentioned before that if I read a textbook that I assign them, I give them a section of a textbook to read. And if something's not clear to me, it's certainly not going to be clear to them. And so my knowledge of physiology research, physiology concepts, I like to illustrate things with graphs. I like to help students with their understanding and what they need to know when it comes to treating patients. And I think that's the beauty of physiology. A lot of what I teach is very translatable. That's going to be knowledge that they will absolutely use when they're treating patients. So very rewarding part of my job.
You said that fascination with the kidney's complexity hooked you early in your career. How do you spark that same sense of curiosity and discovery in your students?
Yeah, in different ways. I will frequently tell students, here's what we're doing in the lab, and this is why it matters. And again, another nice thing about physiology, I mean, a lot of the things that I do in my lab are things that when we go to our annual physical, we're going to get, in the report, blood pressure, indices of kidney function, indices of kidney disease progression. A lot of the things I measure in my lab are exactly what's measured with patient, in the patient care world. Other things I like telling students that there are things that happen, to the body in different procedures that we still don't have a great understanding about. I mean, for example, when someone donates a kidney, the remaining kidney, and then we'll take over about 70% of the kidney that was donated, not 100. What are the signals that tell the kidney to stop growing? What are the signals that tell the kidney to start growing? These are things we've known for a long time, but we don't have a good understanding. And it's those type of big picture things that I like telling students that you can go read literature about this and see what other people think about it. And the last thing is getting back to textbooks. A lot of what's written in textbooks, you gain a lot of knowledge from it, but it's not all fact. It's based on research that was interpreted by different people. And it may not be based on solid data. So drilling down through references in textbooks or papers and really pushing yourself to have a better understanding of why this statement is made in a textbook. I mean, those are all things you can do. I think it's just a curiosity-driven aspect of my job that I like.
What is one piece of advice you would share with students who are considering careers in research, medicine, or academic science?
Yeah, and this spans everybody. Be passionate about what you're doing. You're going to be doing it for the rest of your life. If it's research, if it's academic science, if it's medicine, patient, you're going to be doing it for a long time. So be passionate about it. Take what you do very seriously. Go about your job in the correct way. Learn from what you've been taught, but don't take yourself too seriously. Be humble. Don't develop a big ego. And especially in research, I mean, everybody in research is wrong a lot of the time, but you still see people with big egos and stuff. And I think it's very important to be humble, and that allows me with my collaborators to push each other, to challenge each other when we're trying to interpret data, and to not feel like you're right all the time.
Finally, what impact do you hope you've had on your students?
Yeah, I play a small part in training of medical students, for example. I hope they look back on my lectures and say, yeah, Dr. Polichnowski played a small part, but he was a really important part of me being successful in medical school. That's really all I can ask for. I mean, it's with a PhD student, I hope they go on and have a great career in research. I hope I provide them with all the skills that necessary to have a career. But I teach a lot of medical students, and I get them for mainly the first, second year, and I get to primarily teach physiology to them, but also get to help them get involved in research. But I just hope they look back and say, yeah, he was maybe played a small but very important part in me being successful here.
Aaron, thank you so much for joining us today and for sharing your time, your insights, and your passion for both research and teaching. Your commitment to discovery, mentorship, and student success truly reflects the spirit of ETSU and the heart of why we teach. We are grateful for the impact you make on your students, your field, and our university. Thank you for listening to Why I Teach. For more information about Dr. Polichnowski, the Quillen College of Medicine, or this podcast series, visit the ETSU Provost website at etsu.edu/provost. You can follow me on social media at ETSU Provost. And if you enjoyed this episode, please take a moment to like and subscribe to Why I Teach wherever you listen to podcasts.